Okay, so let's look at section 5.1, part 2. So we've been looking at this where they ask us for the cumulative area to the left of z equals 1.23. So you can see 1.23 is right here. We have a standardized number line here with 0 in the middle and standard deviation of 1. So when we go into StatCrunch, we want to find the probability that x is less than or equal to, because we want to go to the left, 1.23. When we put that into StatCrunch, we get an answer of 0.8907. So that means all of this area here to the left of 1.23 is equal to about 89%. Now for these, we're still going to use StatCrunch, but notice for this first graph, the area is to the right. So what that means is we need to use a greater than sign. Remember, our inequality is going to point in the direction where we want to go. So our z-score is 1.23, but this time we don't want to go to the left, we want to go to the right, and StatCrunch lets us do that. Now, if we use the table, unfortunately, we would have to find the area to the left and then subtract that from 1. So that's all I'm trying to show you here. We do not have to do this. So if you stick with StatCrunch, StatCrunch is going to give us the answer. But it works because the entire curve would be 1, and so 1 minus to the left would be your area to the right. But again, let StatCrunch do that. For the last one, we want to know the area between. So between negative 0.7 and 1.23. So what you're going to do is when you hit the calculator normal, there's a box near the top of the graph where you can hit between. And then this will actually calculate the area using StatCrunch. If you use the table, you have to calculate 2 different z-scores and then subtract them to find in between. That's what's going to happen if you hit help me solve this too. So don't hit help me solve this. Go to your lecture notes or come to this video or reach out to me and I'll help you. All right, so once again, let's look. The question says, find the area under the standard normal curve. So that means mean is 0, standard deviation is 1, to the right of z equals 1.06. So we want to head to the right. We're going to still mark 1.06, which is already to the right of the mean, and then we want the area to the right. So if we were using the table, we would have to first find the area to the left and then subtract from 1, but we do not have to do that with StatCrunch. With StatCrunch, we're just going to change our inequality to greater than so that we get all of the area that's greater than 1.06. All right, let's look at between. So here the question says, find the area under the standard normal curve between z equals negative 1.5 and z equals 1.25. All right, so since we're doing between, once we click into Stat Calculator Normal, we want to click on the between icon here, and then it's going to let you put the numbers in. So you can put negative 1.5 here, you can put the 1.25 here. The mean and the standard deviation are still 0 and 1. And again, what's nice is the graph is going to show you the between. And so all of the area between negative 1.5 and 1.25 will be computed by StatCrunch, and you can see that you get 0.828 if we round. All right, we've talked about unusual and very unusual before. It's very obvious to see where we are when we have a standardized number line. We've got a 0 in the middle, we've got 1, 2, and 3. standard deviations above the mean, those are all to the right. And then we have -1, -2, -3. Those are all standard deviations below the mean, and so they're to the left. For unusual, we want to either be greater than 2, so that's this right here, or less than, I'm saying that wrong, more than 2 below the mean over here to be unusual. Once we pass the 3 on this side or the -3 on this side, then we've gone to very unusual. See how small the area is? So the area right here is very tiny, and that's why we say it's very unusual for data points to show up there. Most of our data points are going to be in the middle. The red shading here, that is unusual. Again, it's a small area, not as small as the very unusual, but small. So once we pass 2 standard deviations away, we're unusual. And then if we pass 3 standard deviations away, we're very unusual. The same thing happens on the other side. As soon as we are 2 standard deviations below the mean, we are at unusual. As soon as we come 3 standard deviations below the mean, then we are very unusual. Okay, so here's a problem like what you would see in the homework. First, it wants to know if it's a normal curve or if it crosses the x-axis or if it's skewed left or skewed right. We've got the skewed down, but crossing the x-axis, you can see this does not cross. I know it makes it look down on each end that it's touching, but it's really not. It's approaching as close as it can to our axis, but it's not actually touching. So this is normal. It's bell-shaped. It's symmetric. And so we're good to go. The first thing they want to know is the mean. So we're going to look at the middle of the curve here, come down. And it looks like it's about at 18. And so our mean is 18. The hard thing is the standard deviation. So an inflection point is 1 standard deviation away. It's where the curve, as the curve comes down, as it kind of changes from being down to kind of moving in a different direction, but that's hard to tell. So what's easier to do is kind of guess about where 1 standard deviation is away. If we pick 3, let's add 3 and see where we end up. So 18 plus 3 would get us to 21, plus 3 is 24, plus 3 is 27. And this looks about right for being 3 standard deviations away. If we picked 4, it would go too far because 18 plus 4 would give me 22, plus 4 would give me 26, plus 4 more would get me to 30. And the problem is 30 is way too far away. So I don't think that 4 is right. I think we want to deal with 3 as our standard deviation. If you have trouble with this problem in the homework, just email it to me and we'll talk about it. Okay, so this problem doesn't actually say much, but it gives you a picture. So it says find the area of the shaded region under the standard normal curve. And we get the graph that's up here. Now I know this is very hard to see, but it gives me down here that the z is equal to 1.88. And then it also shows me, oh, this pen, that the shading is to the right. Okay, so I'm going to go into Stat Calculator Normal. I'm going to come down. I'm going to make sure my mean is 0. My standard deviation is 1. I'm going to head to the right because that's what my picture told me. And then I'm going to put in the 1.88. So my graph from StatCrunch should look like the graph in the problem. And then it will give me the answer. So it gives me 0.030. Now the work up here on top is if we use the table. All right, I highly suggest using StatCrunch and not the table, and just stick with one method so that you don't confuse yourself. Okay, so this problem 2, it says find the indicated area under the normal curve between z equals 0 and z equals 3.02. So I came over here and I drew my curve because I like to see what this looks like. So I drew my bell curve, I plotted 0 in the middle, and then I came over here and plotted 3.02. Because we want the area between those, I went ahead and shaded that in with green. I'm going to add a yellow on top. So I want all of this area between 0 and 3.02. So now I can go into StatCrunch. I showed you that here. I went to the normal calculator. I hit between, and then I popped in 0 and 1 for the mean and standard deviation, and put in 0 for my lower boundary for x, and 3.02, and it gave me the same answer of 0.4987. Okay, so this problem is why you need to draw a picture, because this one we don't want between, even though this problem makes it look like we want between, because it gives us two z's and a couple inequalities, but that's not what happens when we draw the picture. So when you come over here and you draw your bell curve, after I drew the bell curve, I put my 0 in the middle, I drew negative 0.67 over here and positive 0.67 over here. But notice, you got to read really carefully in statistics, we want the z less than negative 0.67. So that's the area over here. And then we want the area, so that was the area less than negative 0.67. Now we want the area greater than 0.67. And so that's over here. And so this is not between. And therefore, we're going to have to use the normal calculator twice. So what I did is I came down here. This first chart is from StatCrunch. I used the normal calculator, and I used x less than or equal to negative 0.67. So that gave me 0.2514. And then I ran the calculator again. So this time I wanted x greater than or equal to 0.67, so that I went on the right side, and this also gave me 0.2514. So notice it's symmetric. That's because our curve is symmetric. And so those answers are the same because we're either less than negative 0.67 or greater than 0.67. So those are symmetric and they're actually the same. But then we need to add those together. Okay, so we have a little different of a problem here. And we do use these a lot for standardized exams. When your kids' teachers, or if you take a standardized exam and you see the statistics, you're now going to understand what's going on with the z-scores and the percentiles. We'll get to that as we go along. But they say we're using a normal distribution, so we can use a z-score. It says the mean was 1,473. That's right here. The standard deviation is 311. That's right here. The test scores of 4 students selected at random are 1,870, 1,220, 2,170, and 1,360. It says find the z-scores that correspond to each value and determine whether any of the values are unusual. All right, so we're going to use our formula for z-score, which means we're going to take the data point that they give us. That goes first. So we're going to take the 1,870. We're going to subtract the mean. So the mean is 1,473. That's going to stay the same for the other scores that you're going to do on your own. And then so that's the mean. And then we're going to divide by the standard deviation. That's the 311. So once you I have a screenshot here of using the Casio. Hit the fraction key first, and then go ahead and put your data value minus the mean on top, your standard deviation on the bottom, and this wants 2 decimal places. So we now know that the z-score is 1.28. That's not unusual. To be unusual, we have to be more than 2 standard deviations away. This is less than 2, and so we're good to go. They're then going to ask you to do the remaining problems. For the remaining problems, or the remaining data points, you're going to do exactly the same thing. So all you're going to change is the data point in the beginning of the formula. The mean and the standard deviation are going to stay the same. And then if any of those are greater than 2 or less than -2, then you're going to be unusual.